Right. Excuse me. Good evening. It is 8 o'clock, so we'll go and get started. All right. So the material for this week that we had to cover was all about Boolean expressions and if statements and else statements and a way to conditionally execute code. And when I say conditionally, it means sometimes there's a piece of code that you want to execute, but only sometimes. And sometimes you don't want to execute it. And using the if statements and else statements is really how we determined whether we want to execute a piece of code or not. So that's what we're going to get to. But let's start off by talking about the Boolean expressions. There's really about 6 Boolean expressions that we can talk about in Python. It's pretty much the same for every programming language, but we're talking about Python. And really, it's just math. A lot of it is just math. And it's the kind of math type things that you would think about, are things equal to each other? Are things not equal to each other? Is something less than something else? Is it greater than? Is it less than or equal to? And so on and so forth. But really, we're just making a comparison between two values. And we want to know, is that comparison, is it true or is it false? That's ultimately what we want to get down to. So let's show a few of those. And we're just going to put them in a print statement. And when we, of course, like you've seen so far, whenever we put something in a print statement, it just prints out what it is, right? Let's just run this and we see, it prints out whatever this is. It prints out the word this. That's old news, stuff we've already done, right? Whenever you do print, whatever you put inside is what gets printed out. Okay. When Python, you also have the words called true. Notice it is not in quotes. So it's not the string true. It's actually a value, and the value is true. Let's save it and let's run it. And you can see it prints out true because we want to print this out and it's true. Likewise, if we put false there, it prints out false, and that's fine. So now let's do one of our Boolean expressions, and we're going to have it print out to us, is that true or false? So if we put, let's say, 5 less than 3, right? Is this true or false? 5 less than 3. Well, that is false, right? Because 5 is not less than 3. So the idea of comparing 5 and 3 together, if we say 5 is less than 3, that's obviously false. So that means this whole thing right here is the value false. So if we run that, we see it prints out false. Notice it doesn't print out 5. It doesn't print out 3. It doesn't print out 5 less than 3. No, Python does this comparison right here. It does this Boolean expression. It determines whether it's true or false. And then I'm printing out, is it true or false? And we can see here, 5 less than 3 is false. If we would put 3 less than 5, that's going to be true, right? If we run that, we see it prints out true. And that is the case. 3 is less than 5. So this less than in here is one of the Boolean expressions. It's one of the ways that we can compare two values. In this case, we're comparing the value 3 and we're comparing the value 5. And this is what we're comparing them with, the less than sign. There are actually 6 of these comparisons we can make. We can make equal. We can make not equal. We can make less than. We can make greater than. We can do less than or equal to. And we can do greater than or equal to. I'll put a little note what each of those means. This means equal to. This is not equal to. This is less than. This is greater than. Less than or equal to. And greater than or equal to. So let's do a little example using each of those. So let's say print 3 is equal to 5. Print 3 is not equal to 5. Print, let's see, 3 less than 5. Print 3 greater than 5. Print 3 less than or equal to 5. And the last one, print 3 greater than or equal to 5. So how many of these are going to be true and how many are going to be false? Well, 3 is equal to 5. That's false. So this one should be false, right? Let's record our answers and see if we get them right. This one, 3 not equal to 5. That's true because 3 is not 5. So this one should be true. 3 less than 5. That's true. 3 greater than 5. That's false. 3 less than or equal to 5. That's false. 3 greater than or equal to 5. That's also false. So that should be what we get printed out. False, true, true, and then 3 falses. Let's make sure that's what we get. And it is. False, true, true, false. Ooh, why is that one true? Did I mess up? Oh, yeah. This one should be true. I made a mistake. Because 3 is less than or equal to 5. Yep, I made a mistake there. Let's run it. And false, true, true, false, true, false. And that's what we get. Okay? So that's how we can compare two values. And it doesn't have to be like a hard-coded number. You can use variables here. We can put A as 10 and B is 17. So instead of 3 and 5, let's use our new variables A and B. Let's get rid of this because that's not always going to be the case now. Actually, let's make them the same number. And let's think through what this should be. So I'm saying A is 10 and B is 10, right? So what are we going to get? That should end up being true. A not equal to B, that's going to be false because they are the same number. Is A less than B? No. Is A greater than B? No, they're the same number. Is A less than or equal to B? Yes. Is A greater than or equal to B? That's also true. Let's make sure we get it right. So we've got true, false, 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 true, true. And that's the case. True, false, 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 true, true. So that's how we can compare numbers together. And you can use decimal numbers too. Say we put 10.1 and 10.1 and 10.9. That's fine. You can compare floating point numbers together. Let's get rid of that. We're not going to manually go through and figure out what it is yet. Let's just have our program tell us. So if A is 10.1, B is 10.9, and that works just fine. It tells us whether that Boolean expression is true or false. Remember, when I say Boolean expression, I'm talking about the whole thing here. The first value, what you're using to compare them, and the second value. The whole thing is the Boolean expression. So we can do that a little bit with strings. You can't do it exactly with strings. Well, actually, you can do it pretty closely with strings. So instead of 10.1 and 10.9, let's make it a string. Let's make this A. We'll actually make it the string A, and we'll make this the string B. You can compare strings like this. So here we're going to say, is the string A the same thing as the string B? Are they different? Is it less than? Is it greater than? Less than or equal to? So on and so forth. And it still works. And here in a second, I'll explain how you need to think about the less than or equal to. Let's just run it. And there's what the answer is. And does this make sense? So we're saying A is equal to B. And it's actually false, right? Because they're not the same string. And that's right, it tells us false. A not equal to B. that's true. They are not equal. So it tells us they're true. Now, the slightly tricky part is when we get down here and we start talking about less than or equal to. Okay. Here's how you need to think about this when you're comparing strings. Is think about comparing a string like you would look up the word in a dictionary. They are compared alphabetically. So for instance, in this third instance right here, we're saying is A less than B. Well, we're comparing those two strings, right? So you think to yourself, in the dictionary, does A come before B? It's yes. So A is less than B. And so that ends up being true. And you see, we do get a true there for it. And it works if they're longer, right? A. That's fine. Let's say we still put A, B, 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 B. We can compare those. There we go. So are they equal? Nope, that's false. And we get false. Are they not equal? That is true. They're not the same. So we get true there. Is A less than B? Is this one less than this one? And that's true. Just like I was saying, if you're looking it up in the dictionary, you know, the first letter does match. Okay, so if the first letter matches, you have to go to the next letter, right? So when we go to the next letter, this one's A and this one's B. Oh, so this one does come first. So it is less than. And so we make that comparison, A less than B, you know, we get it as true, which is correct. Now, here's the part you have to be careful about. All right, let's say we have just AAA and we have AAA. Same thing, right? If we run that, you know, this is what it tells us. It tells us, are they equal, true? Are they not equal, false? Less than, equal to, so on and so forth, right? What if we compare those two strings? Is this going to be true or false? Are they equal to each other? The answer is no, they are not equal to each other. So when we're checking if they're equal, it says it's false. And that's correct because the lowercase letters are not equal to the uppercase letters. There is a differentiation between uppercase and lowercase letters. But so you may ask yourself, okay, which one comes first? Does the uppercase letters come first or the lowercase letters come first? Well, let's make it easy. Let's get rid of all these other things and just compare less than. So we're going to say, are the lowercase letters less than the uppercase letters? And what's the answer going to be? It's going to be false. That's because in Python, actually in all programming languages, when you're comparing strings, the uppercase letters come first. It has to do with the ASCII table, which you don't need to know too much about for this class. But if you're interested in digging deeper, it's because of where the characters fall on the ASCII table. But the uppercase letters are less than the lowercase letters. Okay. And you know, you need to think about that when you're mixing cases. So if you got little a, big A, little a, you know, is this still true? It's actually false because you're comparing the first letter, and since those match, we have to go to the next letter, right? When we go to the next letter, we're comparing lowercase a and uppercase a. But I already said the uppercase comes first. So if we say A is less than B, that's going to be false. What's really going to be tricky, though, is, you know, if you have to think about this and do this, is if this is AAA and this is little BBB, actually, let's do it the other way around, BBB and AAA, which one comes first? Does this come first or does this? You know, if you think about it in the dictionary, and that, well, you have to think about the uppercase letters come first. If we run that, it's still going to be false because this B is not less than A, right? But what really cooks your brain Now, which one is first? This one is still first because all of the uppercase letters are less than all of the lowercase letters. It's just a quirk, not just Python, really all programming languages. But uppercase letters are less than lowercase letters. So actually, if we say B is less than A, is that going to be true or false? Is this less than this? Actually ends up being true, as we can see there. Okay, so that's how you can compare numbers together. That's how you can compare strings together. But how does this help us, right? What does this get us as far as programming is concerned? Well, it lets us do conditional execution. And like I mentioned earlier, conditional execution is, let's say you have a piece of code, but you only want to execute that piece of code under certain conditions. Let's see an example of that. Let's say we're going to say, and we do it with if statements and else statements and else if. We'll get to the other ones in a second, but let's start with the if statement. Here's how we can execute code based on a certain condition. It looks like this. We have if, and then here we're going to put a condition. Then you have to put a colon. And then on the next line, you have to make sure it's tabbed in. Tabs and spacing is actually very important in Python. But we say if this condition is true, then execute this code. And then this is code after the if statement. Let's explain what each of those things mean. So you always have to use the word if. That's just part of Python. Here, you're going to put the condition that you're checking. You want to put something that's either going to be true or false. Just like we showed a few minutes ago. If you compare two numbers together, that's going to be true or false. If you're comparing strings together, that's going to be true or false. Here is where you're going to put one of those conditions that is either going to be true or it's going to be false. After that, you put a colon. Then you go to the next line and you have to put a tab. The tab is very important. Every time after you have an if statement, it will execute all of the code that's tabbed in. This code too. This code also. So if this condition is true, it will execute each line of these three pieces of code, and that's because they are all tabbed in. Okay. After it's done, it'll go down here to the next line that is not tabbed in. Notice how this one is all the way back at the left-hand side. So since this is not tabbed in, it is not part of this if statement. It's completely separate from it. It's just code that exists after the if statement. Let's put some comments on this, because this is like pseudocode. Now let's do some real code with some if statements. So let's do an example of, we're going to ask the user to type in their age. And then depending on their age, we're going to say either you're a minor, you're an adult, or you're a senior citizen, right? So first, let's start by having somebody type in their age. So we'll say the age is equal to an integer of the input. Enter your age. I'm not going to explain that too much. This is stuff we did in the past week or two. Right now, let's just print out their age to make sure we're getting it right. It's really good practice when you're doing your assignments and homeworks that every time you make any kind of little change, you should really stop and run your code and make sure it's working right. Don't try to program up an entire assignment before you try to run it one time. You're likely have gotten something wrong. It's really good practice to make one little bit of code and then execute it to make sure it's working right. So we made one little bit of code. Now let's execute it to make sure it's working right. So for us, we're just going to have them type in their age, and then we just want to print out the age. So let's run it. says enter your age. Let's put 55, and there you go. It prints out 55. Let's do it again with some other age, 13. It prints out 13. All right, so I feel pretty good that that's working, right? All right, so age is now a variable that is how old you told the computer you were. So now we need to think, okay, if I want to tell you if you're a minor or an adult or a senior, I need to check your age against other values, right? I can say if your age is less than 18, then I want to print out you're a minor. Does that make sense? Let's stop there. Let's just run that so far. Make sure it works right. So if I type in 55, it doesn't print out anything. Does that make sense for what we've done so far? Well, here I type my age is going to be 55. I'm saying, is 55 less than 18? That is not true. That is false. Since it is not true, then I don't execute any of this code tabbed in. I skip over anything that's tabbed in and go to the next thing that's not tabbed in. And really, we don't have any more code, so that's why nothing's getting printed. Actually, let's just put a print here. We're going to say after the if statement. Just so we know we've gotten to the code that's after the if statement. Let's run that. When I type in 55, the only thing it prints in is after the if statement. Because like I said, your age is 55. That's what we typed in. I'm going to say if 55 is less than 18, that is not true. So I skip over the indented code. This does not get executed at all. It skips over it. And it goes to the next thing that is not indented, which is right here. It prints that out, and we can see we do get that printed out. So now let's type in an age that is a minor. So if we type in 5, it prints out minor, and then also prints out after the if statement. Does that make sense? Is this working properly? So I typed in 5 for the age. So I'm saying if 5 is less than 18, that is true. Since that is true, I will execute the indented code. And the only thing that's indented is just this printing out that it's a minor. And you see, we do get the minor printed out. And then after it does all the indented code, it just goes to the next line that's not indented, which is right here. So you see, this will always get executed because it's not part of the indentation. The only code here that is conditional, meaning sometimes it gets executed, sometimes it doesn't, is the indented code. Since this is not indented, it gets executed every time. This is not indented and it gets executed every time. This is indented, so it only gets executed when this is true. Hence, when I typed in 5, it does print that out. If I type in 55, it does not do that. Okay, so that's a minor. So how would we do it if we want to check if you're an adult? We could say if your age is less than, if you're greater than or equal to 18, we're going to print you're an adult. All right. Let's run this and check if it makes sense. So if you run it and we put in the 5, of course, it says you're a minor. Notice it doesn't print adult, and it shouldn't. And if we put in 55, it says you're an adult, which is what we expected it to do. Like I said, when you type in 5 less than 18, that is true. So we do the indented code. Then we go to the unindented code. 5 greater than or equal to 18, that's false. So we skip the indented code. It doesn't happen. And then we go to the next unindented, which is right here. The next time we ran the program, we typed in 55. So we said 55 less than 18. That is false. So we skip this. Go to the next line. 55 greater than or equal to 18. That is true. So we do execute the indented code. Print adult, and you can see there we did print adult. And then we did the after the if statement. Okay. And these greater thans and less thans and equal to, we can use it with whatever variables that we want. Doesn't just have to be that. Let's do something with a string. Let's say our name. Enter your name. So I want to say if the name is equal to Dan, we'll print great name. If name is not equal to Dan, print terrible name, right? Let's delete the rest of this stuff. Just show you, we can do it with strings as well. Let's run that. We type in Bob. It's a terrible name because name is Bob. Bob equal to Dan, that's false. So we skip that line. Bob not equal to Dan, that is true. So we do execute that line. And likewise, if we put in Dan, it's a great name. What if we put in capital DAN? What's going to happen? Is that a great name or a terrible name? It's a terrible name. And why is that? Just like I said, when you're comparing capital letters and lowercase letters, they are not the same thing. So I'm comparing capital DAN with lowercase DAN. So capital DAN equal to lower DAN, that's false. Okay, that's the comparison of the string. All right, I want to go back to our age example. Since we did strings, let me undo all this, go back to the age. All right, there we go. So I said there is one more category, right? I said there is, let's say, a senior citizen, right? So we have a minor, an adult, and a senior, right? This is a good place to use else statements in combination with if statements. So let's see how those work. First, let's get rid of this. Let's forget about the senior for a minute and just consider minor and adult, and then we'll add on the senior. So we say, if your age is less than 18, if that's true, print minor. If this is false, let's just forget about Python for a second and think about it logically. If you are less than 18, then you're a minor. Anything else, and you're an adult, right? So it's like in Python, it's like saying, if this is true, you're a minor. Then we could put this word else, colon, print, adult. So what's happening here? Here, I'm still doing this comparison. Is your age less than 18? If that is true, then we execute this statement and we will skip everything with the else. If this is true, we execute this indented code and we skip the else. If this is false, then we skip this and we do the else. So it's like saying, if something is true, do this. If it's false, do that. Let's Execute a couple examples. If we put 5, it says minor. Why? 5 less than 18, that is true. So we execute this and we skip the else. And then we just go to the next line, which is, after the if statement. If we run it with 55, it prints adult. Does this make sense? 55 less than 18, that is false. So we will skip that and we will do what is in the else. That's how the if-else statements work. There's one more wrinkle in here with what we call the else-if statement. So now let's think about with a senior citizen. So, let's say if they're less than 18, they're a minor. If they're greater than 65, we'll call them a senior. If they're anything else, anything in between, we're just going to say they're an adult. So less than 18, minor, greater than 65, a senior, and everything else is an adult. So this part can remain the same. We're going to say if you're less than 18, print you're a minor. Then we have this new concept called an L-if. Now we put another conditional check. We're going to say if you're greater than 65, print you're a senior. I can spell. And then finally, with the else, print you're an adult. So how does this work? Let's use the example. Actually, let's run it and then we'll talk through the example. So if I put 5 years old, it says you're a minor. Let's step through how that's working. So your age is 5. So 5 less than 18, that is true. So we execute this and we skip everything else. All the else if and the else, all of the rest of it gets skipped because this was true. So we skipped everything else. So let's put an age of 70. We run that, it says they're a senior. So how does that work? So we said 70 less than 18, that's false. So we check the next else if. This is just like it's another if statement. But this only gets checked if the first one is false. So 70 less than 18, that's false. So we go to the next check. 70 greater than 65, that is true. Since it's true, we print out senior and we skip everything after it. Well, all of the else if statements after it gets skipped. And we just go to the next line, which is here. That's how it works with 70. Now let's put in 55 and it tells us we're just an adult. So all three of our inputs gave us the correct answer, but let's talk about 55. So 55 less than 18, that's false. So we go to the next check. 55 greater than 65, that is also false. So we go to the next check. Well, this one doesn't have an if statement attached to it. So this will just get executed every time. Well, every time these are false. So when we put in 55, this was false. 55 with this is false. And so we go here. There's no if, there's no conditional check. So this will just always happen. It tells you you're an adult. And that gave us the correct answer for all three of our inputs. For example, if we put exactly 65, it still tells us we're an adult. Because that is false. 65 less than 18 false. 65 greater than 65 is false. So we end up right here at this else statement. Okay. We can also have what we call nested conditional statement. Let's do an example with that. It's really no different than just the conditional statements that we've done here for this example. But when we say they're nested, we just mean there's a conditional statement inside of another conditional statement. So let me think of an example here. Let's do something with the age and the name. So let's ask user their name, input, enter your name. And then we get how old we get their name and we get how old they are, right? So let's just think of a scenario here. Let's say if your name is Dan and you're over 50 years old, which I'm not, but this is just an example. You're a great guy. So we're looking for if your name is Dan and if you are older than 50 years old. So let's think about that in code. So if the name is equal to Dan, if your name is Dan, we want to do something, right? Else, do something else, right? So let's start off with not a nested. Let's just start off with the normal one. We're just going to say print great guy. And here we'll print terrible guy, right? This is kind of the same example we did earlier, really. But after we test this, we'll add a nested conditional into it. So let's run it. We type in Bob and your age, 55. It's a terrible guy. If we type in Dan and 55, it's a great guy. Really, so far the age is irrelevant because we're not doing any checks with the age. We're not doing any conditional checks with the age, but we're going to add one. So first we just check if the name is Dan. So if the name is Dan, now we still don't know if he's a great guy. Let's say he can be a great guy or an okay guy, but it depends on how old he is. So let's check his age. If his age is greater than 50, he's a great guy. Else, he's an okay guy. This is what we call a nested conditional statement because we have this level right here of a conditional statement, this if statement with this check. Then we tab in all the code. All the code that's tabbed in is what we want to execute if this is true. So if this is true, we do all of this, right? But inside here is another if statement with another check and another indentation, and that's fine. So if this is true, we execute this. Okay, now while we're executing this, if this is true, we execute that. Else, we execute that. And then it goes to the, like we had before, after the if statement. I just put that in there so we can see it printed on the screen. And we know it got to this point, right? So let's run it. So let's think about how we can test this out. First of all, let's put in a name that's not Dan. Bob, 44. It says terrible guy. Let's think about how this gets through here. So first says, if the name is Dan, so we say Bob is equal to Dan. That's false. So we skip over all this and we just do the if statement, which is terrible guy. So that works out right. Same thing works out if we put Jim, right? Terrible guy. What happens if we put Dan and we put in the age of 50? Okay, guy. Let's think about how this got through there. So Dan equals to Dan, that's true. So now we're executing this code. So now we said, I typed in 50 for my age, so 50 greater than 50, that's false. So I skip this and go to the else statement, and I print out okay guy. And then I skip everything else, and then I'm after the if statement, which that's what happens. So now let's say Dan, 55, that's a great guy. Okay, so we said Dan equals to Dan, that's true. Now we're inside here. 55 greater than 50, that's true. So we're inside here. And now we can skip over the rest of the else and all these if statements, and we go to the line afterwards. All right, so that works like we think it does. So this isn't a very useful example. Let's do somewhat of a more realistic example with these if statements. And then after that, we'll talk about some test cases and we'll start wrapping it up. Okay, so let's imagine you're going to the zoo, okay? And you're trying to buy tickets for the zoo. And so, kids get in for whatever amount, adults get in for a different amount, and seniors get in for a different amount, right? So let's say you're going to the zoo, right? This is going to be a little bit of a longer example, but it's something you can build off of for your assignments if you need to. So let's say we need to know how many kids are going, how many adults are going, and how many seniors are going. So let's say num kids is equal to the input, how many kids going, or how many kids tickets, right? We're buying tickets. That's the number of kids going. Let's ask how many adults and how many seniors. So num kids, num adults, num seniors. So how many kids? Actually, that's not, that example isn't going to work out because it's not an if statement. Well, we can make an if statement out of it. All right. How many kids? How many adults? And how many seniors? All your tickets, right? And let's say the standard ticket is $10, right? Kids tickets are 50% off, right? That makes sense. We're gonna say the standard ticket is $10 and a kid ticket is 50% off, right? The adult ticket is full price and the senior ticket is, let's say it's 70%, right? So that's how much each ticket costs, right? So a standard ticket costs $10. The kids ticket is 50% of that. The adult ticket is the full price, and the senior ticket is 70% of it. All right. So let's calculate what the cost of all the tickets should be. So the cost should be the number of kids times the kids ticket plus the number of adults times the adult ticket plus the number of seniors times the senior ticket, right? That should be the normal cost, right? So let's just print out. Normal cost is whatever the cost is, right? And here a second, we'll do an if statement. So let's just run this, make sure it works. So number of kids, one kid, one adult, and one senior ticket. So the total cost is $22. Does that make sense? Let's think about it for a second. So if the 10, so a kid should be $5, an adult should be 10, and a senior should be $7, right? If you add those up, you get 22. So this computed it correctly. Let's add some. Let's say you get 10 kids, 55. It's a tour group, right? And 6 adults. Yeah, there you go. It's going to cost you $642. So we have a good program that computes how much you got to pay and cost to go to the zoo. But now let's say, are they going to get some kind of like group discount? So say discount equals, do you get a group discount? And, enter Y or N, yes or no. So now we need to give them a discount if they answer yes. So if what they type in, instead of calling it discount, let's call it answer. So if the answer is equal to a yes, then let's just say we're only going to charge them 75%. And we'll say Then we'll tell them, well, you get a discount. You get a discounted cost at, whatever the new cost is. So this is like a more realistic program. So let me describe each step. Then we'll put in some numbers and make sure it's working right. So here, I'm just getting input from the user. I'm asking them how many kids, how many adults, and how many senior tickets they want. This is computing the price of each ticket. So a normal ticket is 10. A kid gets in for half price. An adult pays full price, and a senior pays at the 70% rate. Here, I'm just doing the calculation. This right here is just simple math. I'm not going to explain multiplication and addition, but here I'm computing the total cost. And then I would just want to print to them the normal cost is whatever we computed. Now I'm going to ask them, here's where we get to the conditional execution. I'm going to ask them, do you get a group discount? Yes or no? Y or N. If they answer a yes, then I'm going to give them a discount, compute a new cost, and I'm going to tell them how much it costs. Let's run it. So let's say there's 5 kids, 5 adults, 5 seniors. So normally it costs $110. Let's say, no, we don't get a group discount, so you just pay the $110. Let's run the same program with 5 kids, 5 adults, 5 seniors. The normal cost is $110, but for some reason, yes, we get a group discount. So you get a discounted cost at $82.50. So what happened here in this second example with 5, 5, 5, and yes, a group discount? So we said 5 kids, 5 adults, 5 seniors, price of each ticket. We compute those costs with 5 adults, 5 kids, 5 adults, 5 seniors. We told them that the normal cost is whatever that computation is right there. We asked them, do you get a group discount? We answered Y for yes, we get a group discount. And since answer equals Y, that was true, we execute this code inside of here. So we actually give them a group discount. That's where your conditional code comes into play. In a real program, ask, do they get a discount? If they get a discount, you want to give them a discount. If they don't get a discount, then you don't compute a discount. So that's kind of a more realistic example of this conditional execution. Okay, so that's all the new coding material. The next thing I want to cover before I open it for any questions is test cases, and it really test report. So for your last assignment, you did have to create a test report, and I was actually extremely lenient on your test reports, and that's because specifically test reports and test cases didn't really go into much depth until this week, but you have an entire section devoted to talking about test cases and test reports. So on this assignment you have due coming up in a few days, and all future assignments, your test report needs to be in a very specific format, and it needs to have all the required information. If it doesn't have all the required information, and if it isn't in the proper format, there's going to be a point deduction for it. So let me show you what the proper format and proper or what the required information in the test report is. So it works really good if you put it in a spreadsheet or a table. You don't have to. Let me find my program here for a table. I think I can put it, not text editor. Oh, I don't have it installed. All right, I'm going to do some ASCII art example. Now, what program you use to make your test report, I'm not worried about it. You can make it in plain notepad if it's legible. You can make a table in a document. That helps a lot. It can be in a spreadsheet. That's fine. But what you're really looking for is a table. So let's keep this program here and let's make a test report for this program. There's really 5 columns that is required in your test report. The first column is the test number, NUMBER. The next column is the input. The next column is your expected output. The next column is your actual output. And the last column is result. All of your test reports must contain these columns. So what goes in these columns? For test number, it's easy. You just sequentially number them. It starts with 1. We'll do 3, 2, and 3. It's going to be 2. There's going to be 3 test cases, all right? So now I think about what is the input? And that is, what does the user have to type into your program? For this program, we're typing in the number of kids, the number of adults, and the number of seniors. And we also have to type in yes or no if they get a discount, right? So in a test case, let's say I'm going to have 1 kid, 1 adult, 1 senior, and I'm going to say no, they don't get a discount. So for my test, that's going to be the input. 1 adult, 1 kid, 1 adult, 1 senior, and I'm going to say no to group discount. Now I have to think, what should be the answer my program gives me? So for the amount that I have to pay, what is the answer? The key here is that you have to compute this manually. When I say manually, you can use a calculator. Using a calculator is fine. But you either need to work it out by pen and paper, or you can use a calculator. That's fine. But for expected output, you do not, I repeat, you do not use what your program tells you. That is what goes in the actual output. And I will show you why that's extremely important. So let's compute, what should my program tell me is the answer if that's the input. Well, let me get a calculator going. I think I have a calculator on here. Yep, there's a calculator. So I already figured out, an adult is $10, a kid is $5, and a senior is $7, right? So if I have 1 kid, that's $5. If I have 1 adult, that's $10. If I have 1 senior, that's $7. And I said no to a discount. So it should cost me $22. So I'm going to put that for my expected output. All right. Before we are going to have to execute that, but let's come up with the other inputs first. For my test case number 2, let's say 1 kid, 1 adult, 1 senior, but yes, we do get a group discount. So let's manually compute that. So one kid is $5, 1 adult is $10, 1 senior is $7. But we are getting the group discount, and that's at 75%. So that answer should be $16.50. So that should be $16.50. Let's do one more test case. Let's say it's 5, 6, 7, and yes to a discount. What should be the answer? Again, note, I'm doing this with the calculator. You do not do this with your program. So we got 5 kids at $5 each. We got 6 adults at $10 each. And we got 7 seniors at $7 each. So normally it would be that, but we are getting the discount. So with the discount, we do times 0.75. And so that should cost me $100.50. All right. So that's how you do your expected output. You look at the input to your program and you manually compute what the answer should be. That's what we've done here. Now for actual output, you do run your program, you give it that input, and you write down and you put in this table what your program said the answer was. So let's run this program. You run it with the input of your table, so 1, 1, 1, and no. So 1, 1, 1, no. The answer is $22, so that's my actual output. All right, let's do the next one. See, we did 1, 1, 1, and yes. So 1, 1, 1, yes. My cost is $16.50. That's the output from my program. Let's do the last one. See, 5, 6, 7, and yes. And my output for my program is 100.5. So now we fill out the last column. So the result is either a pass or a fail. And what you're doing, you compare the expected output with the actual output. If they match, then it passes. If they don't match, it fails. Luckily for me, each of mine passes. My actual output is the exact same as my expected output. What this means is, this is what I know the answer should be this. And since my program gives me that answer, then it passes that test. Okay. So why is this useful? It's really the most useful to let you know, is your program working correctly or not? So let's see where this would fail. Okay, let's say it's supposed to be 75%, but I fat fingered it and put 78. What we were trying to do, we're trying to give a 75% discount. This is what we really want to do. But let's say I messed up something in my program. I accidentally put in the wrong number here. Okay. So let's get rid of this actual output and the pass or fail result. So the first part remains the same. This is still my test number. This is still the input I want to receive, or the input I want to give it. And here, this is still what I expect the answer to be. I still expect it to be $22. I expect it to be $16.50 because I do want to give a 75% discount. So now let's run our program. Let's run it with our first test case. 1, 1, 1, no. 1, 1, 1, no. All right, we get actual output of 22. So actually, right now, it still passes. Let's do our next test, which is 1, 1, 1, yes. 1, 1, 1, yes. It tells me 1716. That's my actual output. Well, now, these no longer match. So for that, my result is a failure. Let's do the last one, the 5, 6, 7, and the yes. 5, 6, 7, yes. Tells me this is just a rounding error. Don't worry too much about the rounding error. 104.52, 104.52. That also fails because this is what I expected the answer to be. This is what my program told me. So something's not right here. And that's the key reason why you want to use a test report, is you're really looking for these fails. If something shows up as a fail, it really means you have done something wrong in your program. You have programmed it incorrectly. And if you have programmed it incorrectly, you need to find out what you did wrong and you need to fix it. Because, for example, let's say if you would turn this in for an assignment, I would read through your code and I'd be like, oh, you have an error in your program, and I would take points off because you did it wrong, right? But here, since you're doing a test table, you are finding out for yourself you did something wrong before you even submit the assignment. So this is telling you you need to go back and fix something before you turn it in. Or if you're programming for a real company and you're doing some kind of program for them, this is telling you, okay, you have messed up the program. You need to go fix that program before you start selling it to customers. So, since these two things failed, we need to look back through our program for where we went wrong. And we get, oh, here is what we did wrong. It's supposed to be 75. I accidentally typed 78. Let's change it to 75. Since you went back and fixed your program, the actual output and the result, they go away now because you changed your program so it could give you a different actual output and different result. So since we changed it, let's run it with our test cases. 1, 1, 1, no. It's 22. 1, 1, 1, yes, is 1650. And 5, 6, 7, yes, is 100.5. And you'll notice, this is a pass, this is a pass, and this is a pass. So in that case, it's very likely, although not 100%, but it's very likely that you did your program correctly and you could turn it in. There are cases where you could still have something wrong, but still pass all your test cases. If you make your test cases so simplistic, or maybe you make them in a way that doesn't test out all your code. For example, let's put our error back in there, right? This is still our error. Let's delete this because we changed the code. So we have our error in there. Let's say all of our test cases, though, we say no, right? I'm not going to waste time going through those now, or manually computing them. But if we said no for each one of those, then that means we never execute this code, do we? If I say no, 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 this is never true. This code is never executed. So we probably would have the expected and the output to pass. All of these would probably pass, even though we do have an error. So you need to design your test cases so that every part of your program gets executed. That's pretty important. So that's what the test report looks like. That's how you need to do it. This is what your test report needs to look like. It needs to have all 5 of these columns. It needs to have all of the data filled in to get full credit. If it doesn't have all this information, you will not get full credit for your test report. And now I will tell you the one biggie that will get you 0 points on your test report. Let's say you had this error, right? This is still an error in your program, okay? Let's say you didn't want to put forth the effort to manually compute it, right? Well, let's change these back to what? To the yeses. So you decided, those are the test numbers. This is the input. And you don't want to do the effort to manually compute the expected output. So what you do is you go in here and you just run your program. Say 111 no. So my program said 22. So I'm just going to put 22 and 22 and it passes. All right, let's do our next one. Let's do 111 yes. All right, my program tells me it's 1716. So let's just put that for both of these columns. And oh, it passes. And then, of course, the last one, 5, 6, 7. Yes. My program tells me it's 104.52. So I just put that for both columns. And you say it passes because they match, right? Doing this, what I just did will get you a 0 on your test report. And that's because, is this true? If I see this, it is telling me really you fraudulently did your test report. Because, whenever I'm looking at your homework and grading your assignment, I see this error. I will catch that error. I'm saying, oh, you have some kind of error in your mathematical calculation. And then, so I look at your test report because I think to myself, if you have an error in your mathematical computation, your test report should have caught it. But here, when I see that the numbers still match and the numbers are equal to whatever your program outputted, then I know you didn't manually compute this number. You just looked at whatever your program told you and assumed it was the right answer. So when you have an error in your program and you just copy the values like that, when you don't manually compute it, you're not going to catch the error in your program. So when I see you have an error, and if I see, these things still match, I know you didn't manually compute that. And I consider that a fraudulent test report. And at least for the test report portion, you will get 0 points. So make sure you're doing the test reports appropriately. And it's really for your benefit to make sure to help you catch the errors in your program before you turn them in. Okay, so that's the material for this week. That is all about test reports, all you wanted to know about it. So I will open the floor up for any questions you may have. You can either unmute yourself and ask, or you can type them in the chat box. Nothing heard so far. I will stand by about 1 more minute if you have any questions. Just like last week, the session is being recorded and will be posted. If you weren't able to make it, so you can view it, or if you were here and you want to check it out later or replay something, then you're more than welcome to. Do you have a question? Is there a way you can provide us with the test template? This is the test template. Like I said, you can do it like this, kind of with the ASCII art like I did. It's kind of difficult to do it like this, but you can do it like this. If you have like Excel or some kind of spreadsheet program, just have these for each column. Or if you have a Word document, if you do like insert table and have all these columns and rows, that's all you need. It's not really so much of a template as it is arranging your test into columns and rows and making sure you have all 5 of these columns. All right, stand by about 1 more minute. All right, we'll go ahead and wrap it up then. If you have any questions or issues, the earlier you let me know, the better. The most preferred method is via email because I get notifications on those and I can usually respond to you pretty quickly. But I mean, if you ask me for assistance at 10 p.m. on Tuesday night, I am a human being. I go to bed, so it's unlikely I will be able to get your response in time. So the earlier you can ask a question, the more likely it is that I will be able to help you out before your assignment is due. And of course, if you're asking for help, what I ask from you is, be specific in your question. Let me know exactly what is going wrong. If you just say my program doesn't work, that's not very helpful. You need to be something like, I tried to add these two numbers on line 10 and it's giving me the wrong answer. That's a specific question and that's fine. So make your question specific. Let me know what you have already tried to do. If you have a problem, you need to kind of try to reason through it and figure it out. If you can't, that's fine. Ask me. I have no problem helping you. But at least let me know what you've already tried to do. And then lastly, attach your program, your Python code to the email. Now, the UMGC email system, if you attach a file with the extension .py, it actually removes the attachment. So change the extension to like .txt and then attach it and it'll make it through. But please attach your code with any request for help because it's a lot easier for me to see what's going on. All right, we'll go ahead and wrap it up. Everyone have a good night. And sometime by tomorrow morning, I will have this video posted so you can review it. All right, good night.